Nonfoliated metamorphic rocks. Nonfoliated metamorphic rocks are a diverse group of rocks that undergo metamorphism without developing a layered or banded structure. Unlike foliated rocks, which exhibit a distinct alignment of mineral grains, nonfoliated rocks lack this characteristic feature. Instead, their minerals recrystallize and reorganize in response to heat and pressure without exhibiting any preferred orientation. One of the most common types of nonfoliated metamorphic rocks is marble. Marble forms from the metamorphism of limestone or dolostone, typically in the presence of high temperatures and pressures. During this process, the calcite or dolomite minerals in the original rock recrystallize, resulting in a crystalline structure that lacks any obvious layering or foliation. Marble is prized for its beauty and is commonly used in architecture, sculpture, and decorative purposes. Another significant nonfoliated metamorphic rock is quartzite. Quartzite forms from the metamorphism of quartz-rich sandstone under intense heat and pressure. The grains of quartz in the sandstone recrystallize and fuse together, creating a dense, hard rock with a granular texture. Quartzite is highly resistant to weathering and erosion, making it a valuable material for construction and as a dimension stone in architectural applications. Schist is another example of a nonfoliated metamorphic rock, albeit one that can exhibit some foliation under certain conditions. Schist forms from the metamorphism of shale or other fine-grained rocks, typically through the process of regional metamorphism. While some varieties of schist may exhibit a layered or banded appearance due to the alignment of mineral grains, others can be nonfoliated, with minerals such as mica, chlorite, or garnet recrystallizing without any preferred orientation. Nonfoliated metamorphic rocks also include hornfels, which forms from the contact metamorphism of rocks adjacent to igneous intrusions. Hornfels typically lacks any discernible layering and can exhibit a wide range of colors and textures depending on the composition of the original rock and the nature of the metamorphic process. Overall, nonfoliated metamorphic rocks encompass a diverse array of rock types formed under different geological conditions. While they lack the pronounced layering characteristic of foliated rocks, they are nonetheless important in understanding the processes of metamorphism and the geological history of the Earth's crust. Nonfoliated metamorphic rocks origin. Nonfoliated metamorphic rocks originate from a variety of geological processes and environments, each imparting unique characteristics to the resulting rocks. These rocks undergo metamorphism without developing the distinct layering or foliation observed in foliated metamorphic rocks. Instead, their mineral grains recrystallize and reorganize in response to heat and pressure, often resulting in uniform textures and structures. Here's a more detailed exploration of the origins of nonfoliated metamorphic rocks. Contact metamorphism. One of the primary origins of nonfoliated metamorphic rocks is contact metamorphism, which occurs when rocks are subjected to high temperatures and pressures due to the intrusion of molten magma. In contact metamorphism, the surrounding rocks are heated by the intrusion, leading to recrystallization and alteration of their mineral composition. Nonfoliated rocks such as hornfels commonly form in this environment, where the heat from the magma alters the texture and mineralogy of the surrounding rocks without inducing significant deformation or foliation. Regional metamorphism. While foliated rocks are often associated with regional metamorphism, where rocks undergo intense pressure and heat over large areas, nonfoliated metamorphic rocks can also form in this setting. In regions of high tectonic activity, such as mountain building processes or subduction zones, rocks can be subjected to significant heat and pressure without developing distinct foliation. Nonfoliated rocks like quartzite and marble can result from the regional metamorphism of sandstone and limestone, respectively, where the minerals recrystallize and compact without exhibiting preferred orientations. Burial metamorphism. Sedimentary rocks buried deep within the Earth's crust can undergo metamorphism due to the increased temperature and pressure with depth. This process, known as burial metamorphism, can lead to the formation of nonfoliated rocks like quartzite from quartz-rich sandstone or marble from limestone. The minerals in the original sedimentary rocks recrystallize and reorganize under the conditions of burial, resulting in the development of nonfoliated textures and structures. Hydrothermal metamorphism. Hydrothermal fluids circulating through fractures and faults in the Earth's crust can cause localized metamorphism of the surrounding rocks. This process, known as hydrothermal metamorphism, can lead to the formation of nonfoliated rocks such as quartz veins and certain types of marble. The introduction of hot fluids rich in dissolved minerals can alter the composition and texture of the host rocks, resulting in the formation of nonfoliated minerals and textures. Dynamic metamorphism. In regions of intense tectonic activity, rocks can undergo metamorphism due to the shearing and deformation associated with faulting and folding. While dynamic metamorphism often produces foliated rocks, certain conditions can result in the formation of nonfoliated textures. Rocks subjected to high strain rates and deformation without significant recrystallization may retain their nonfoliated character, with minerals such as quartz and calcite showing little or no preferred orientation. Overall, nonfoliated metamorphic rocks originate from a variety of geological processes and environments, each contributing to the unique textures and compositions observed in these rocks. From contact metamorphism near igneous intrusions to regional metamorphism in tectonically active regions, the origins of nonfoliated rocks provide valuable insights into the complex processes shaping the Earth's crust over geological time scales. Nonfoliated metamorphic rocks formation. The formation of nonfoliated metamorphic rocks involves a complex interplay of geological processes that result in the alteration of existing rocks without the development of distinct layering or foliation. These rocks undergo metamorphism due to changes in temperature, pressure, and chemical environment, leading to the recrystallization and reorganization of mineral grains. Here's a detailed exploration of the formation of nonfoliated metamorphic rocks. Recrystallization. One of the fundamental processes involved in the formation of nonfoliated metamorphic rocks is recrystallization. Under the influence of heat and pressure, the mineral grains in the original rock undergo changes in size and shape, with new crystals forming in equilibrium with the surrounding environment. This process helps to erase the original texture and structure of the rock, resulting in the development of a new, more uniform texture characteristic of metamorphic rocks. Phase changes. Metamorphism often involves phase changes, where minerals undergo transformations into different crystal structures or mineral compositions. For example, in the formation of marble from limestone, the calcium carbonate minerals in the original rock undergo recrystallization, transitioning from the fine-grained, sedimentary texture of limestone to the coarser, crystalline texture of marble. Similarly, in the formation of quartzite from quartz-rich sandstone, the quartz grains recrystallize and fuse together, forming a dense, hard rock with a granular texture. Pressure solution. Pressure solution is another important process in the formation of nonfoliated metamorphic rocks, particularly in rocks containing soluble minerals such as calcite. Under pressure, minerals can dissolve at points of contact between grains and precipitate in areas of lower stress, leading to the development of interlocking grains and a more compact texture. This process contributes to the formation of rocks like marble, where the calcite minerals recrystallize and bond together to form a solid, crystalline mass. Fluid infiltration. Fluids play a crucial role in metamorphic processes by transporting dissolved ions and facilitating mineral reactions. In the formation of nonfoliated metamorphic rocks, fluids can introduce new elements or compounds into the rock, leading to the growth of new minerals or the alteration of existing ones. For example, in hydrothermal metamorphism, hot fluids circulating through fractures and faults can introduce silica-rich solutions, leading to the recrystallization of minerals into quartzite. Metasomatism. Metasomatism refers to the chemical alteration of rocks through the addition or removal of elements or compounds. This process can occur during metamorphism and contribute to the formation of nonfoliated rocks with distinct mineral compositions. For instance, the addition of silica-rich fluids during metamorphism can lead to the formation of quartzite from sandstone, while the addition of carbonate-rich fluids can result in the formation of marble from limestone. Metamorphic grade and conditions. The specific conditions of temperature and pressure experienced by rocks during metamorphism influence the type of metamorphic rock that forms. Nonfoliated metamorphic rocks typically form under conditions of high temperature and pressure but without the development of significant directed stress or deformation. The absence of foliation in these rocks indicates that the minerals have recrystallized without preferential alignment, resulting in a uniform texture and structure. Overall, the formation of nonfoliated metamorphic rocks is a complex process involving the interplay of various geological factors, including temperature, pressure, fluid composition, and mineral reactions. Through recrystallization, phase changes, pressure solution, fluid infiltration, metasomatism, and other processes, existing rocks undergo transformation into new metamorphic rocks with distinct textures, compositions, and properties. Nonfoliated metamorphic rocks types. Nonfoliated metamorphic rocks encompass a diverse array of rock types, each with its unique mineral composition, texture, and geological origin. Despite lacking the pronounced layering or foliation characteristic of foliated rocks, nonfoliated metamorphic rocks exhibit a wide range of textures and structures resulting from the recrystallization and reorganization of mineral grains during metamorphism. Here's a detailed exploration of some common types of nonfoliated metamorphic rocks. Marble. Marble is perhaps the most well-known nonfoliated metamorphic rock, prized for its beauty and versatility. It forms from the metamorphism of limestone or dolostone, typically in environments of high temperature and pressure. The calcite or dolomite minerals in the original rock recrystallize into larger, interlocking crystals, resulting in a dense, crystalline texture. Marble comes in a variety of colors and patterns depending on the impurities present in the original limestone, with popular varieties including Carrara marble and Calicut marble. Quartzite. Quartzite is a hard, durable rock that forms from the metamorphism of quartz-rich sandstone. Under intense heat and pressure, the quartz grains in the sandstone recrystallize and fuse together, creating a rock with a granular texture and high silica content. Quartzite is resistant to weathering and erosion, making it a popular material for construction and as a dimension stone in architectural applications. It often exhibits a light-colored, granular appearance and can contain other minerals such as feldspar and mica. Hornfels. Hornfels is a fine-grained, non-foliated metamorphic rock that forms from the contact metamorphism of rocks adjacent to igneous intrusions. The heat from the intruding magma alters the mineralogy and texture of the surrounding rocks, resulting in the formation of hornfels. Hornfels typically lacks distinct layering and exhibits a range of colors and textures depending on the composition of the original rock and the nature of the metamorphic process. It often contains minerals such as quartz, feldspar, and mica, with the specific mineral assemblage reflecting the composition of the parent rock. Quartz-rich rocks. Certain nonfoliated metamorphic rocks are dominated by quartz minerals and exhibit a granular or crystalline texture. These rocks include quartzite, as mentioned earlier, as well as rocks such as metaquartzite and metaconglomerate. Metaquartzite forms from the metamorphism of pure quartz sandstone, while metaconglomerate forms from the metamorphism of conglomerate rocks containing quartz pebbles. These rocks typically have a high silica content and are resistant to weathering and erosion, making them valuable as construction materials and decorative stones. Calcite-rich rocks. In addition to marble, other nonfoliated metamorphic rocks are dominated by calcite minerals and exhibit a crystalline texture. These rocks include calcite marble, which forms from the metamorphism of pure limestone, as well as rocks such as skarn and marbleized limestone. Skarn forms from the metamorphism of carbonate rocks in contact with igneous intrusions, resulting in a mixed mineral assemblage that may include calcite, garnet, and other minerals. Marbleized limestone refers to limestone that has undergone extensive metamorphism, leading to the development of a crystalline texture resembling marble. Amphibolite. While amphibolite is typically considered a foliated metamorphic rock due to its mineral composition, certain varieties can exhibit a nonfoliated texture under specific conditions. Amphibolite forms from the metamorphism of basaltic rocks such as basalt or gabbro, typically in regions of high-grade metamorphism. In non-foliated varieties of amphibolite, the mineral grains recrystallize without significant alignment, resulting in a uniform, granular texture dominated by minerals such as amphibole, plagioclase feldspar, and quartz. These are just a few examples of the diverse range of non-foliated metamorphic rocks found in the Earth's crust. Each type of rock reflects specific geological processes and conditions of metamorphism, resulting in a variety of textures, compositions, and physical properties. Understanding the characteristics and origins of non-foliated metamorphic rocks provides valuable insights into the complex processes shaping the Earth's crust over geological time scales.